We interrupt this broadcast of systems to talk about matrices. So we're going to learn about matrices, matrices, in order to use them to solve systems. So let's dive in. So first, what is a matrix? So we're going to talk about two different types of things. I know it says matrix dimensions. We're going to talk about that in half a second. But what is a matrix, first of all? So a matrix, we're going to talk about kind of two different types of numbers. We're going to talk about a scalar later. Scalar, which is just a number like 5 or 6 or -1/2. Those are scalars, right? And you can represent a scalar with a variable, usually a lowercase. Now, a matrix is almost always represented with an uppercase, something like an A or a B or an L or whatever, right? It's almost always represented with an uppercase letter. And a matrix is basically just a grouping of rows and columns, okay? So something like this. We put a matrix inside these big brackets. And so something like -3, 5, 1, 0, 8, -2, 1/2, 3, -18, 0, 0, 1/3, right? So this matrix here has 1, 2, 3 rows. These are rows, right? And it has 1, 2, 3, 4 columns, right? And that is how we name the dimensions of a matrix. So this is a matrix. Oops. It should be like a full bracket, right? So this is a matrix. So we're looking at kind of a table of values. They can be expressions, they can be letters, all those things, but usually, especially right now, we're talking about numbers in this matrix. So this example matrix would be a 3 by 4 matrix. We name the size of a matrix as row by column. Okay? So that's how the size of a matrix works. Now, if we can do operations with matrices, just like you can do with regular numbers. We can multiply them, we can add them, subtract them, all those things. So if we're going to add and subtract matrices, so this example right here, it's going to be easiest to explain the concept by just jumping straight into an example. So if we're going to add and subtract matrices, so we've got 3 matrices. Matrices is the plural of matrix, right? So we have 3 of them. We have a 2 by 2, a 2 by 2, and a 2 by 1, right? We want to, for each one of these matrices, we want to find each of the following. So we want to do A plus B, and we want to do B minus A, and we want to do A plus C. So let's take a look at how we do this. It's really, really easy. So to do A plus B, we're going to write it out kind of in long form first. So A is 1, 2, -3, 4. And then B is -2, 0, 5, 3, right? So to add these, we just add them by each individual element. So we do this one plus this one, and then we do this one plus that one, and then we do this one plus this one, and we do this one plus that one. So we do add each individual element up, and we end up with a matrix. So when we're adding, and this is important, this is going to matter for later for different other operations we're going to do. So when we're adding two matrices together, you end up with a matrix answer, okay? And so this one, you do them each individual space. So 1 plus -2 is -1. 2 plus 0 is 2. -3 plus 5 is 2. 4 plus 3 is 7. It's that simple. So this right there is A plus B. That matrix right there. Okay, see what we do there? So let's do this one. Now, subtraction, we do the same thing. We just got a minus. Now, the order, just like subtraction with regular numbers, the order matters. So we're going to add kind of a little extra note that B, in most cases, there are some rare exceptions to this, but in most cases, B minus A does not equal A minus B. And that's important to note, that the order matters, right? So here, we're going to do B, which is this one, -2, 0, 5, 3, minus A, which is 1, 2, -3, 4. Right? So here we're going to do subtraction. So we've got -2 minus 1. So -2 minus 1 is -3. 0 minus 2 is -2. Now this is where we get interesting, right? Because we've got 5 minus -3. 5 minus -3. What do we got to do with those? We've got to ka-chink those. So it turns into 5 plus 3, which is 8. 3 minus 4 is -1. So this little matrix right here equals B minus A. Now this last one. So we're supposed to do A, which is 1, 2, -3, 4, and then we're supposed to do C, which is 8, 1 in this 2 by 1 matrix. So how can we add a 2 by 2 plus a 2 by 1? Well, we can't. We can't actually do addition and subtraction if we can't do addition and subtraction unless the matrices have the same dimension. So since this one doesn't have the same dimension, we can't do that. Do this. Not possible. Okay, so they have, in order to add or subtract matrices, they have to have the same dimension. That's very important. That's why we threw that as an example. Okay, let's do another one. So what if we were multiplying by a scalar? So just a number. So this is also really easy peasy, right? So we got the matrix, we got this matrix P, and we're supposed to find -3P. So make this big old deal. -3 times, I'm going to go ahead and put the times, you wouldn't have to, but it's just going to add some clarity in there, make sure we can see what's going on. And then we've got the matrix 1, 2, 0, -3, 5, 9, 8, 7, -6. So we've got a 3 by 3 matrix times a scalar. So when we're multiplying times a scalar, it's really simple. You just take and multiply this times every single element in the matrix. So this would equal, so -3 times 1 is -3. -3 times 2 is -6. -3 times 0 is 0. -3 times -3 is +9. Negative times negative is positive. -3 times 5 is 15. -3 times 9 is -27. -3 times 8 is what is that, 24? Yeah, 24. -3 times 7 is -21. Oh, I made a mistake. That should be negative, right? Oops. -3 times 5 is -15. -21, -3 times -6 is +18. All right, let's kind of put those things together. Let's kind of put these two things together in one last example, and then we'll be done. So if A equals that matrix and B equals that matrix, find -4B minus 3A. So we're going to you do this the same like order of operations that we've always done. We multiply first and then we do addition and subtraction, all of those things. So let's take a look at this guy. So we've got -4 times B, which is -4, -8. 2, negative 3, minus 3 times the matrix A, which is negative 9, 12, 2, negative 6. Okay, so we got to do this one piece at a time. So we're going to do these multiplications first. So that's easy peasy. Negative 4 times negative 4 is positive 16. Negative 4 times negative 8 is positive 32. Negative 4 times 2 is negative 8. Negative 4 times negative 3 is positive 12. Same thing here. So negative, we're going to bring down this, and we're going to write down plus, because I'm going to go ahead and distribute that negative in there. You see how that kind of went a little bit crazy? It's kind of like whenever you distribute, so if I have negative 2 times 5, let's see, let me put a 8 right there, just random. 5x plus 3. I don't know, making something random up. If I distribute this in here, this could totally be 8 plus negative 10, right? That's the same thing. It's the same idea. We're taking the negative, we're distributing it in there. Okay? Making sense so far. Now you could do this one different way. You could, it would be totally possible. And actually I was just looking at my notes that the notes there actually do it the other way. You could leave the negative on the outside and do that in a minute and subtract these instead of adding, but I'm going to front load the subtraction. You could distribute the negative or you could just leave it out there. I'm going to go ahead and distribute it. You could do it either way as long as we deal with the negative somehow. You'll get the same answer either way. In fact, you can test that theory if you want and see that you end up with the same answer if you do it the other way. So negative 3 times negative 9 is positive 27. Negative 3 times 12 is negative 36. Negative 3 times 2 is negative 6. Negative 3 times negative 6 is positive 18. Okay? So you might notice, I'm going to just say this out loud so you can see. So if I had done and left the negative out here, then I would have done 3 times 12 is positive 36. But then when I would have subtracted it, I would have done 32 minus 36 because the negative would have still been out here, which would be the same as 32 plus negative 36. So see, you can do it. That's what I'm talking about. You could actually do that either way. They both work. Okay, so let's do this addition at the end. 16 plus 27 is 33. 43. 43. 32 plus negative 36 is negative 4. How are we doing with notes so far? So far, we're doing great. Negative 8 plus negative 6 is negative 14. 12 plus 18 is 30. The rest of these examples have not been straight out of the notes, but this last one was, so I can double check it, which is good because I didn't learn my lesson and it's kind of getting late in the day when I'm recording this, but try to get it done now. So anyway, if you're one of my students, thanks for being here. I'll see you in class. Do your homework, all of those things. If you're not one of my students, thanks for joining us. Hope this was useful. We will see you guys next time. Bye-bye.